So because you have already been to your lab session, I don't think I need to repeat my lab session expectations anymore. I'll just go right into the milestone 1 code. So for your milestone 1, this is the top level structure of the code that you'll have. Let's wait for everyone to settle down.
Everyone to my home. If you just know, a lot of people are so probably.
Okay. Yeah, from this week onwards, all the tutorials will be in this room only. Okay, let me continue. If anyone's not here, I have the recordings posted and I'll do the same tutorial in the second hour again. So for your milestone 1 code, you have the read-only streets database library. So this library includes street database API and the OSM database API. These are not modifiable. These are read-only. These are just there so that you can access data about the maps. There's the main executable that's run by you. This is called whenever you run your program. There's the tester executable that's used to test your code as the auto tester. Both the main executable and the tester executable are going to communicate with your street map library. This is your wrapper library that wraps to the streets database library. So you'll do all of the data loading queries, data cleanup in the close, and whatever. You'll be implementing all those functions in milestone 1. So to start milestone 1, you really need to read the handout from top to bottom. This is seriously what should happen. To pass your performance test, you will need at least 1 global variable. And anyone has an idea on why? We'll be going through why in our example in this tutorial, if you don't have an idea yet. For your global variable, you should be choosing from the containers from the STL on which container to use. And let's go into how your map is stored, how you should be accessing your map. So your map will be represented by intersections, which are like nodes on a graph, and street segments that are edges that connects both 2 intersections together. Each intersection has an intersection ID that goes from 0 to number of intersections minus 1. Each street segment has a street segment ID that goes from 0 to number of street segments minus 1. These IDs could overlap because they are of different types. There are also other entities like streets. Each have a street ID that goes from 0 to number of street minus 1 and etc. In your m1.cpp and your main.cpp code, you're currently given a load map that's being called every time your program is started, every time you open a map. It's given in map path. And there's the close map that's called every time you close your map. In your load map, you might be loading some data structures here and make sure to clean them up in your close map. If you need to reuse some of the data structures in another map. So for M1, the first steps without modifying any of the functions, compile and run ECE297 exercise 1. And you'll see something like this. It says there's a build error of the unit tests saying there are undefined references to a lot of the functions. These functions are defined in m1.h. For each of the function, you should see a line saying the specification of the function and the line with the speed requirement. What you need to do to overcome the compile errors is to make empty stop functions for those. And in this tutorial, I'll be using this function as an example. I'll be implementing this function, and you're free to use the code from this tutorial in your own code. So we create empty stop implementation of each function in m1.h. You don't have to implement anything yet. If it needs to return something, return a 0 for a number, an empty vector for vectors, and etc. Until there's no more build errors with the ECE297 exercise command. And this is so that you can test your functions individually using the tests. In this case, because all of the functions are empty, you should be failing all of the tests. We have functionality tests that tests only for the correctness of your function. And we have performance tests that test for the timing complexity of your functions. There is a test for load map just to make sure that you're not abusing the load map ability of doing a lot of redundant code and anything like that. For Valgrind, we are testing your memory leaks, memory access. Your goal for M1 is to pass all of these tests. And let's go into the example function that we'll be covering in this tutorial. So in the comment above this function, it says it returns a vector of all the street segments connected to an intersection. So it returns a vector of street segment ID, and it takes in the intersection ID of an intersection. So what it does is that it needs to somehow know the data for this intersection, and it should obtain the information for the street segments connected to this intersection, and it should somehow return the street segment IDs in the vector. So we need to use something that's outside the scope of the function. And that's why we need to call the streets database API.h. M1.h and streets database API.h, and potentially the OSM database API.h are important files that you should be reading from top to bottom, including the comments in the code. For example, the information for each street segment is stored in the struct street segment info. For each street segment, it stores its OSM ID. The OSM ID is the universally unique ID that's given to any entity in the map. So this universally unique refers to it's unique within all of the entities, including the street segment, the intersections, and etc. And it's unique across all maps. So it's a huge number. Intersection ID from and to, because one street segment connects two intersections together. Whether it's one way, the number of curve points in the street segment, the speed limit, the street ID that the street segment belongs to. And there are a lot of structs like this for each of the entities. The functions that are related to the function we're implementing are these ones. This function get non-intersection street segment takes in the intersection ID, and it returns the number of street segments connected to the intersection. The get intersection street segment then returns the street segment ID for each of the street segments connected to the intersection. And then the get street segment info gets the street segment info struct for the street segment ID. The naming convention in the street database API is generally a get signifies this is a lookup, and usually this takes one time. Entity intersection. This is the thing that you're looking up for, and it's usually the first argument in the argument list. We're looking up something related to intersection, and in this case, it's the number of street segments. And that's the general naming convention. You should have a naming convention amongst your teams for the names that you are creating, just for the coding style purpose. For example, if we are looking at the intersection at St. George and Galbraith, this intersection has an ID 232 and it's connected to 3 street segments. So get non-intersection street segment 232 should return 3 or 3 street segments. Then get intersection street segment 232, and we go from 0 to number of street segments returned here, 0 to 3 minus 1 for each of the street segment IDs. After we get the street segment IDs, we can do whatever we want with them. Like we can get the street segment info using the street segment ID and etc. Just be careful that the intersection index, street segment index, and all other indexes are type defs to int. So your compiler will view it as int. The compiler doesn't understand that there is a type change between them. So even if you accidentally swapped them, your compiler is not going to give you any error. The compiler is going to assume that you're doing the right thing. So make sure that in your naming conventions for your variables, in the name for a street segment index, you should have the name street segment in the name. For intersection index, you should have the name intersection in the name, or at least something related to that so that you're not mixing up the usage. And back to our example function that we're implementing. Remember, we want to push all of the street segments as street segment indexes that's connected to the intersection here into the vector, into the return vector. How would you do this? Any ideas? And you will likely need some of these function calls. Let's take some time to write it down, like in a text editor or something. So we want to get the street segment IDs of the street segments connected to the intersection and push them into the return vector.
I think you can take something like. Yeah, yeah, that's all. Always like, that is.
Okay, let's get back. Everyone should have at least an idea on how to do it. So what is the first step? Yeah. Yep, call get num intersection street segment to get the number. Yeah. To get how many street segments there are. And then we loop through all of them and call the get intersection street segment for each of them. So we loop from 0 to get num intersection street segment, intersection ID -1. And in each of the iteration, we call get intersection street segment, intersection ID, and I. And we push back whatever's returned from here into the return vector. And try it out in the tester. You can run one tester each by using this command, ECE297 exercise 1 -- run tester. Start intersection start tells the tester to only run the tests with the intersection in the name. And what we will see is that the intersection test's functionality test was passed, but the performance test is still failing. And this is because this function is not fast enough. In m1.h, there's this chunk of comment saying the speed requirements for each of the functions. For high speed requirement, this function must be very, very fast and is likely to require creation of data structures, global data structures that allow you to rapidly return the right data rather than going into the streets database API and building the vector each time. Moderate, this function is speed tested, but you can do it in a more straightforward way, like calling the proper streets database API functions or a more brute force way. Now this function is not speed tested. For the function that we are looking at, it has a high speed requirement, so we will need to do something for that. Probably some pre-processing. Let's look at the code that we have. Assume all the get functions are O1. What is the complexity for this function? Yes? ON? We use OK because it's not really a defined N. What is K in this case? K is the average number of street segments connected to the intersections. So if we want to speed up our function, rather than creating the vector inside the function itself, we might need to create the function beforewards. And there's a massive hint in m1.cpp. Inside load map, there is the line of comment here, load your map related data structures here. So we need to use a global data structure that's loaded here for the intersection street segments function. What data structure can we use for the intersection street segments function? So this function takes in as input an integer intersection index. The intersection index is an integer that ranges from 0 to get num intersections -1. This is a continuous range. The output is the collection of street segment IDs. as a vector of int. So we want something that takes in as input an integer that's of a continuous range starting at 0 and output a vector. Here are some of the STL data structures. The vector takes in an integer as index and output templated type. List uses iterators, output templated type. Map uses templated key, output templated value. Our map input templated key, output templated value. Remember, vector is like an array. List is linked list, doubly linked list. Map is binary search tree. Our map is hash table. Which data structures can be accessed with an integer? Intersection ID. First thing to consider, which data structures can be accessed with an integer intersection ID? All of them. With different timing complexities, but all of them. You can use integer index into a vector. You can use integer keys because the keys are templated for the maps. And for the list, it's inefficient, but you still can access with an integer. What can these data structures contain? Anything, because they're templated, including vectors of integers. What is the complexity of accessing single elements in the data structure? And we have the complexities for each data structure. And we want something that's less complex than O of n or O of k. So that's probably we should be choosing from vector and ordered map. Both of them has O1 complexity, but for vector, an access involves a direct memory access, load the starting address of the array with an offset. So it's a single direct memory access. On word math, first needs to call a hash function to get an index and then do a direct memory access. And the hash function could get long, at least longer than a single memory access in the vector. So vectors are indexed using a number. It is a continuous range that the first element starts at 0, the last is at size -1. So if you are using an index into some sort of data structure, nothing can beat a vector. When input is not an index, say if we are looking up with a string, or if we're storing something that's just not an integer, we should be using our word map because our word map is still O1. Or if we are looking up with a really big number that doesn't necessarily start at 0 and there are gaps between numbers and numbers, use hash. Like if you are indexing using the OSM ID, because it's such an enormous number that is too big and most entries will be empty in a vector. That's a waste of resource. So use our map in this case. And you will have usage of this. So we choose vector in this case because we're indexing from 0 to number of intersections -1. So the global variable will be a vector of integer. What's this look like? Street segment index is a type def to integer. So we have a vector that goes from 0 to number of intersections minus 1. And each entry contains a vector of integer. And this should store the street segment IDs connected to each of the intersection. So if you want to access intersection 1's street segment IDs, just access intersection street segments square bracket 1. And that's a single memory access. And because load map is called whenever you open up a map, this is where you do all of the data pre-processing. And this is where you should be doing the population of the intersection street segments. So we first resize the intersection street segments outer vector to be the number of intersections, because we know the exact size for that one. And this will create empty vectors for each intersection. Then in the for loop, we can directly do pushbacks. This for loop goes from intersection 0 to the last intersection, get num intersections minus 1. And in our for loop, it does the same thing as what we just did in the function. So we push back into the global variable intersection street segments indexed by the intersection ID. So this is a vector. So we push back the street segment IDs into it. Is this clear? So after load map, you will have a global variable that's loaded with the street segments connected to each intersection. Is it good? Then in the function itself, find street segments of intersection, we just directly return the vector that's at the index intersection ID. One line or one. Is this good? Then after we run the test again, we should see that both the functionality and the performance test should pass. There is a performance test for load map too, so make sure you are not doing something crazy in it. You have several seconds to load everything into the data structures, and that's long enough to load in everything you need. Just don't go crazy and do some redundant stuff over and over again. Okay. So that's the last slide. I'm showing this test summary as passing, but there are more to test in each of the tests. So don't worry if you don't see it show passing. As long as you're not seeing in the log that the function is failed, then it passes that single test. There are more to test in each of the intersection tests than the single function here. And yeah, I'll reserve the rest of the first hour to questions on milestone 1. And I put the link to the video on how to resolve git conflicts under the milestone 1 tutorial 3 page if you need to refer to it. You have to know how to resolve Git conflicts because that is not going to be taken as an excuse for uneven Git commits, for example. And yeah. You may ask any questions to me, and if you don't have any questions, and if you don't want to listen to the same tutorial again in the second hour, you may leave.